Busier today, eh? Lots of people walking around. Testing, testing. Better? Excellent. So for those of you who may not have caught that, our first midterm is going to be on March 5th, our second being on April 2nd. So you don't have to worry about it being this week, because it's not this week. Any questions before we get started? Anything procedural? Anybody wants to talk about? All right, might as well get started then.
Professor Guy.
Oh, sorry. Yeah. That's a good question. What assignment content will be on the first test? So normally, I don't test on the stuff that we cover the week of, but I test on everything starting stopping at the end of the previous week. So since the previous week in this case is going to be reading week, the test will cover all the way up to and including numerical computation, which is up to the end of next week. Cool. Any other question? Good. All right. Let's continue our journey into the depths of programming, shall we? So, last time, we were talking about dictionaries. We had covered lists, we had covered sets. We were just about to get into one of the more useful data structures that exists in Python, dictionaries. So a dictionary, roughly speaking, is a way of creating a connection between two elements of two different sets. In this case, it's all of the things that you can make a variable equal to, right? So strings are totally valid, integers, floating point numbers, all totally valid, booleans also valid. What a dictionary does is it creates a mapping between one object and another. So, for example, if we have this, and incidentally, I apologize for, I don't know what you want to call this, freckle vision? I'm going to call it freckle vision. I apologize for the freckles, but I can't do anything about them. Hopefully they don't pick up on the camera, but anyways. So if we have a dictionary, days in month, we relate the abbreviations signifying the months of the year to the number of days in those months. This way, if you want to see the number that corresponds to the number of days in any particular month, what you do is you access it by providing it a string. With dictionaries, we call these key-value pairs. This is the key that unlocks the value. With me so far? So far, so review? Hopefully. Good. So, an interesting thing about dictionaries, the empty dictionary is actually empty parentheses. You may have been going through the set material for it with us and wondered why set didn't have empty curly braces, just like, list 7, the square braces, etc., etc. And the reason is that curly braces are already occupied by dictionaries, and dictionaries are far more important than sets. Sets are, not of supreme importance when it comes to, that sort of thing. Yes?
What's the difference between a dictionary, assigning a bunch of different variables?
So the question is, what's the difference between a dictionary assigning a bunch of values and just making a bunch of variables? Well, there are a number of differences. The first of which, I would say, if you create a bunch of variables, they all have to have unique names. But you can create a bunch of dictionaries that all have the same keys, right? So I could, in theory, going back to the previous example, if I had, months of the number of days each month is on Earth, I could say Earth month in years. If I wanted the number of, days in every month on Mars, I could have Mars, and it'd be a different dictionary, but you'd still have January, February, March as the keys. So in that way, it's a way of better organizing your data slightly. The other thing about a dictionary is you don't have to have a string as the key. You can also use integers or floating points as the key. You can even use certain types of objects, I believe, as keys. So there's that one. And your question kind of gets to a more fundamental point about data structures in general, actually, which is, why even bother with them when you can actually reproduce much the same functionality just using a bunch of variables, right? There's really not a huge, let's put it this way. If you declare a list that has 50 elements in it, and you declare 50 variables with numbers embedded inside of the variable names, you can do pretty much exactly the same thing with those two up to a point, right? The trick becomes when you want to start numerically indexing things, because that's where the variables will fall down, and lists will elevate themselves onto a fantastic pedestal for you. Their awe and majesty shall unfold before you like the dawning of a new universe. So, if you do things with variables, like lots and lots of variables, what you lose is the modularity to be able to write code to deal with them. You end up having to deal with them all by hand, right? This is, inefficient and costly. You have caused confusion and delay. But yeah, you can use variables for all of this. In fact, there's this interesting property of computation called Turing Completeness, which is something you'll probably have heard about in 1JC3 if you have taken it or are going to take it. As you go on in computer science courses, you'll more likely run into this concept. But who knows who Alan Turing is? Good. So Alan Turing is the great-grandfather of computation as a science. He and his doctoral supervisor, Alonzo Church, who invented lambda calculus, came up with a theoretical result called the Church-Turing thesis. What this essentially says is that any program which is expressible as a Turing machine is equivalent to any, like it can be written in any other way that it can also be rewritten into a Turing machine, essentially. So we have this interesting result in computation where basically if you have an algorithm, if that algorithm is computable, it is computable by any Turing complete language. So Python, being a Turing complete language, can express any algorithm that any other programming language can write. The question is, how convenient is it, right? Because certain languages are set up to be more convenient for some purposes, other languages are more convenient for others. That's why you get, like, thousands of programming languages. They all serve a different purpose. Not equally well, but, So, but it's interesting, right? Because this result, this theoretical result, does not just apply to languages whole cloth, right? This result also applies to subsets of languages. So essentially, if you have a small subset of Python, say variable, reading and writing variables, if statements, and while loops, that's a Turing complete subset of the Python programming language. Meaning any algorithm that you may wish to write can be expressed completely and wholly using only those 4 constructs. Plus literals, but who counts literals? So basically, once you have a good grasp of conditionals, loops, and variables, you can write any program. The problem is, how quickly can you do it? Because it is definitely possible to have a program that would take you so long to write that it's not like... There are programs that you could write that would take you longer than the universe has been around to write, that you can express more easily using the more advanced constructs, right? So, and I'm not exaggerating when I say that. There are, particularly with runtime, it is very easy to write a program that would require longer than the age of the universe to execute. So this is sort of getting back into, when we were talking about, all this kind of stuff at the beginning. But yeah, so it's not just, could I not express this in lower constructs? And the answer is always going to be yes. You can always express stuff in a lower construct. And in fact, that's once you figure that out, that's actually a really good safety net, But again, it's a matter of speed, and speed does matter. But anyway, so in addition to having the empty set, we also have a search operation, a delete operation, a size of operation. We can find the size of a dictionary, and we can isolate the keys and the values. These, I believe, spit them out into tuples, but I could be wrong about that. You should check that quickly. So E1 maps to A, 2 maps to C, D dot keys, dot keys. There we go. Thank you. So it expresses itself as a special data structure. You can always cast these things to a list or a tuple or whatever data structure is convenient for you. Good. So, tuples are mutable. You can modify the value by knowing the key. Similarly to a list, all you have to do is perform an assignment statement, and that will overwrite the existing value. An interesting thing, though, about insertion, because you may have noticed we didn't have an express insertion operation here. In order to insert something into a dictionary, all you have to do is find a key that's unused and perform assignment with it. Does that make sense? Are there any questions? Yes?
Does the key need to be a string?
No. No, the key can be anything.
Oh.
So, we're going to see an example of this coming up, actually, where, okay, so with lists, you have to start at 0 and go to whatever n is, right? Whatever the size is. With dictionaries, you can use whichever integers are important, and you can, like, ignore the rest, right? Like, if you wanted to, let's say you wanted a dictionary which mapped, like, 3 to A and 7 to B, right? If you wanted to use a list to do this, you would have to declare the list, slots 1, 2, 0, 1, 2, 3, 4, 5, 6, and 7. And then in this one, you would slot A. In this one, you would slot B. And then in the rest, you put some kind of a null value, right? That's how you would do that with a list. List. If you wanted to do it with a dictionary, very simply, you just need 3 and 7. That can save you a lot of space, because you don't have to declare all of this extra space, right?
Okay.
Make sense? Any other questions? Yes?
Is there any way to access the key by using the other name of the thing is? But like can you call it in the same way that you like call it using the key and gives you the value? Can you call the value and give it the key?
No.
Okay.
And I'll tell you why. The values are not necessarily unique,
Oh, right.
right? In order for, so the question is, could I, we can get to the values through the keys. Can we get to the keys through the values? And, pardon me. The answer is no, because the values may not be unique. So, if, for example, in this case, if both of these guys pointed to A, if we wanted to get back to a key from A, which one would we choose? We don't know. So the algorithm would not be deterministic, or it would return all of them or something. And there are applications where you expect a collection of keys that all have the same value, but you would write an algorithm for that. That's not the way that it runs by default. Question? That's an excellent question as well. So the question is, can you have multiple values pointing to one key pointing to multiple values? And the answer is yes, if you embed them in another data structure. So if you had, for example, A, B, and C, and you had 1, 2, 3, 4, 5, 6, 7, 8, 9. A dictionary like that does store multiple values per key, but it does require that you put another data structure inside of the data structure. So this is something that's important to know. The data structures that we've been talking about can be nested. So this is actually the way that matrices are represented in computing. So what is a matrix? Nobody? Come on, somebody knows what a matrix is.
A way of representing linear systems.
Is somebody what?
A way of representing linear systems.
A way of representing linear systems. You know what a vector is? Yeah, a matrix is just a two-dimensional vector. Okay. So a vector, if you had x, y, z coordinates, right? It's 3, 7, 8. This is a vector, right? a matrix is like 0, 1, 1, 0, 1, 0, 0, 1, 1, 0, 3, 2. That's a matrix, right? I guess they don't do matrices in high school anymore, do they? Linear algebra, yeah. You would have seen this if you'd taken linear algebra, first year of linear algebra. But they used to teach this in high school. Anyway, matrices are extremely useful, right? So I want you to imagine a field like this, right? Maybe put like one more row on it. Now imagine that the zeros are blank spaces, the ones are red checkers, and the twos are black checkers. This is how a lot of things are represented in computing. This image that you see before you is represented in this fashion. Actually, technically speaking, it has 3 of these, one for the red, blue, and green channels of the image display. So what you're seeing here is a constantly updating 3 matrices representing color values that are being sent to the projector several times per second, and that projector is projecting them onto the screen because it's reading the matrix. So how do you represent a 2-dimensional data structure inside of Python? Any ideas? Yeah?
List within a list?
A list within a list. Or to be more specific, several lists within a list. So all you have to do is that. Does that make sense? I know we're kind of going off the slides a little bit, but 2-dimensional data structures are something that we are going to be covering in tutorial if you haven't already. But yeah, so it's essentially like this is really useful and important to know how to do. But you'll have some time to acclimatize to it. But there's an assignment question coming up which everybody hates, which asks you to make a dictionary of dictionaries. So look forward to that one. Same principle as over there, but with dictionaries. Good. So, oh great, I've got a line now. Nobody sneeze or the thing's going to blow up. Yeah?
Can in a dictionary 2 keys have the same value?
2 keys can have the same value, but no 2 keys can be the same.
Yeah, so each key is unique, but they can have the same value.
Yes. Yeah. Python only places uniqueness constraints on the keys. It doesn't actually care at all what's going on with the values. Values can be anything. Question at back. Could you speak up a little bit?
Sorry, the example from the previous slide, can you explain why output 47
Yeah. So in this line, we declare the dictionary, right? This is a brand new dictionary we're declaring. We are associating the string CO1 with the number 46 and the string CO2 with the number 153. On the next line, we take CO1 and we set value equal to 47. So that overwrites the existing value in the same way that it happens for variables, right? On the next line, we take CO2 and we increment it by 1. This is sort of plus equals 1 just increases whatever that number is by 1. So we end up with this, and then we create a new one, CO3, assign it 0. So in the end, CO1 will have a value 47, CO2 will have a value 154, and CO3 will have a value of 0. Sound good? Question?
If you just print 12 bits, it will give you like 47, 154, and 0.
I think printing it will display everything. Yeah, let me use this one that I have here. Oh my gosh. Print. Come on. E-R-I-N-T. D. Yeah. So this is what it looks like when it prints it. Any other questions? These are good questions. Yes?
You concatenate dictionaries?
Can you concatenate dictionaries? Concatenation isn't really a thing that makes sense with dictionaries. So when you concatenate two lists, essentially it's easy because they all have a positional sort of, like both of them have a positional arrangement, and by concatenating them, you're putting the two arrangements together end to end. Like a better way to phrase it with a dictionary would be you merge the dictionaries, right? And the problem with merging dictionaries is what do you do if the two dictionaries contain the same key? Because they're allowed to, right? So you have to work out a merger algorithm that knows what to do when two things have the same key, like maybe you add the values, maybe you average the values, it depends on the application. But it requires more decisions, right? These are really good questions. Any other questions? Perfect. All right. So, so here's an example where we're using dictionaries to construct a histogram. Who can tell me what a histogram is? Yeah?
It's like a bar graph, but it has like a range instead of, it's basically a bar graph with a range for like hundreds of bars itself, instead of having like an individual value, it's just a range.
Right. So it's frequency, right? A histogram tells you how frequently something happens in a particular set. So in this case, like if we took a histogram of the word doorbell, we get one D, two O's, an R, an E, or a B, an E, and two L's, right? So this is the histogram algorithm. We declare an empty dictionary. For each character in the string, pretend all of these are strings for a moment, even though it's Python, so they're not necessarily strings because it's Python, but we'll pretend that they're strings for now. For character in string, if the character is not in the dictionary, we put it in the dictionary and give it the value 1. If it is in the dictionary, we take it and we add 1 to it. When we have finished all of that, we return the dictionary. So, yeah. Let's, yeah, I think I've got time to do this one. So, let's see here. Define histogram. Takes S. D is an empty dictionary. For C in S, if C is not in D. Remember, this searches the keys, not the values by default. If you're confused about, like if you can't remember whether it's keys or values that it searches, you can always just specify. just write in keys or values, and then you'll get what you want, regardless. Then D at C is equal to 1. Otherwise, D at C already exists in the dictionary, so we want to increment it by 1. At the end, we return, there we go, D. So, if we print the histogram for string, lots of people think that Pokemon Legends is good apparently, but I'm not sold. I've been burned too many times. And we run that. I thought this worked. There we go. There you go. So you can see, this is a count of all of the different characters that occur inside of that string, including some interesting ones that you might not even think are characters, like space. You can see 19 spaces in there. Right? So there you go. Any questions about that? Yes, sir? Dictionaries don't really have an ordering. So, there would be, like, if you took it and you converted, like, the keys to a list and then the values also to a list, or maybe if you, like, deconstructed each of the key value pairs into a tuple and then ordered made a list of tuples and ordered it by the first element of the tuple, then you would be able to do it. But you don't have a dictionary anymore. You would have a list of tuples, right? When it comes to dictionaries, one thing that's really important concept for dictionaries is that the idea of ordering doesn't apply to them, right? And this is actually this is something that you find more generally in discrete mathematics if you go on with it. Not everything has an ordering property, right? Like, think about, for example, a box of M&Ms, right? While you may have your personal preferences with respect to M&M colors, even though it's completely arbitrary because M&Ms aren't actually flavored according to their colors, they're just chocolate. But anyway, incidentally, Smarties from the UK, if you get an orange one, they actually taste like orange, and the brown ones are coffee, but none of the rest of them are flavored. They're all just, the rest of them are just chocolate, but anyway. So if you have M&Ms, right, big bag of M&Ms, it's not obvious what the first M&M is, right? Like, you get a first M&M if you reach into the bag and you pull out an M&M and you eat it, that's like first, but it's because you performed an operation on it. The thing that is not inherently ordered in and of itself. Now, the problem with dictionaries is, like, it's not obvious what should come first. Like strings, characters, floating point numbers, integers. Like, in theory, like integers and floats, you can do the regular ordering of them. But it's not obvious how strings work into that. So really the best thing to do is dispense with the idea that dictionaries have an ordering. Does that make sense? Cool. Any other questions? Boy, you guys are asking really good questions today. Yes? Yeah, sure. So the keys are the means of access, just like keys in real life, right? So you have a key, you insert it into the dictionary's key slot, you turn the key by doing a read operation, and out pops the value. So if I had, for example, the key E, and I pop it in, turn the crank, I get 11 out of it. So, yeah, it's just kind of like nomenclature that you have to memorize. Yes.
And just like a follow-up question, if you were to put key values instead of keys, would there be a big difference? Like in the program?
Yes, there would be a huge difference. Because the values that we're using here are completely numeric, but the elements of the string are all characters. So if I tried searching through a bunch of numbers for a character, I wouldn't find one ever, right? And I think probably eventually that would result in a duplicate key error. We can run that though. See how it works. Let's take a look here. Just for the sake of interest, if we ran this with values instead, we'd probably run into, oh, interesting. Okay, so it didn't flunk out on an error like I expected it to. But you'll notice that everything's got 1, right? So I think what's happening, yeah. So what's happening here is C is always not in values, right? So always it's this line that gets executed, never the other one. So we're not actually counting the characters anymore. We're just reassigning 1 to that slot every time we encounter one. Make sense?
Yeah, and that's because of the sentence that
Yeah, it's because we're searching d.values, not d.keys. Yeah. Yeah, very, very important to keep your values straight from your keys. Good. Any other questions? Excellent.
May I take a picture, please?
Oh, yeah, sure. Go ahead if you want to take a picture. If anybody wants to take, no flash photography, please. No. Okay. This is all also being recorded, so. Good. Okay, good. Excellent.
Excuse me, Professor. So in this code, C refers to a key or to a
Character in the string,
Oh,
right? Because the C is established by the for loop. Remember for loops from last week, right? So S is the data structure that we're looping over. C is sequentially each individual element of that data structure in sequence, right? And it runs the loop once for each one of them.
so the keys are a string.
Yeah, well, yeah. In Python, yes, but in any other language, they would be a character. Because Python confuses the difference between characters and strings. But yeah, so, you know, for example, the first time this loop runs, it would have C equaling L. The next time it would be O, then T, then S, then space, etc., etc., etc. Right? Make sense?
Yeah.
Good.
So the space, why the space concept?
Because it's a character.
Oh,
If it's not a character, then it doesn't print. Well, that's actually not true. Lots of characters don't print. You hit spacebar when you get a space, right? It's not like the computer keeps blank space for it. It has a character code, right? So it's a character. Even though we don't think of it as being a character, in English, it is in a computer. Question? Because I'm inserting it into the dictionary with an initial value of 1 because I found one of them so far, right? It's like, let's say we're actually inserting the space character, right? So if we're right here and we're inserting this character does not yet exist in the dictionary, right? So we take it, we insert it into the dictionary. We have found one of them so far, so we initialize that value to 1. Any further ones that we find, we will increment the value so that it, the next one we will have 2, but only because we incremented that element in the dictionary. Make sense? Good. Any other questions? Sorry, this gentleman behind you.
Sorry, what if we want to do it by words and not letters?
What if you want to do it by words and not letters? Hey, that's an easy one. S dot split on space. Ta-da! You got a question?
Same question.
Cool. So what the split method does, it traces through the string, looking for the character that I've specified, in this case space. And anytime it finds it, it's like, okay, that's the end of one thing. I'm going to go on to the next, right? And then it collects up all of these individual things it finds into a larger data structure. You don't have to use space. If you want, you can split on, the letter A, if you want. And then it splits every time it finds an A. Make sense? Any other questions? Okie dokie. I was kind of worried when we returned to the in-person, because I really, I was worried that, the chat feature from the online lectures wouldn't translate very well, because, people are a little bit more nervous in person about asking questions. But I'm really happy that you guys are actually engaging with the material. It's really nice to see. Because Lord knows I've given lectures where people weren't engaging with the course, with the material. Good. So we can use for loops to iterate over the keys in a dictionary. So for loops, you can use them on lists, you can use them on tuples, you can use them on strings and sets. You can also use them on dictionaries, and you get the keys as the thing that gets assigned to the loop variable. So, that's an important thing to realize, right? Because if it's not that way, you have to know whether or not you're addressing it, right? So, for example, if we go back to this guy, if we say for k in, let's just assign this to D, capital D, sure, why not? For k in D, print k, and then print D at k, and with, say, something like that. There you go. Right? So K is the key. D at K is the value. This is a fairly easy thing to fix if you get it wrong. You just, flip the way that you're doing it. But if you're having a problem and you don't know what it is, and you're getting the wrong side of the dictionary, it's probably because what you think is the value is actually the key. Make sense? Any questions? Yes. Could I repeat it?
Yeah, it's beautiful again.
Yeah. So K is the keys when you use it in a for loop like this. In order to get the value, you have to access the dictionary using our standard notation, right? So K itself, when you print it, that's the keys. When you print D at K, you get the actual values out of the dictionary. Good. Wonderful. Why don't I just close that? So. So this is kind of a fun one. So here's a bunch of different types of data. Let's see what we think appropriate data structures would be for these. We're not going to do it as like a poll, though. That would take too long. So, top 5 nominees for best animated film. What type of data structure do you think would be appropriate?
Dictionary.
Eh?
A dictionary.
What would the keys be?
I guess the keys could be the name, and then the values could be the rank, 1 through 5.
Yeah, you could do it that way. Anybody else? No? Yeah, like for a lot of these, multiple will apply. Yes.
I would say a list, probably.
Yeah. So the top 5 nominees, right? Here's the question to consider: is there an ordering? Not yet. They're just the nominees. Once the winner has been selected, then you have an implied ordering. So actually, a set would be fine for this as well. But again, like pretty much any data structure will work if you use it correctly. Shopping list for pizza ingredients and their amounts.
Dictionary.
Dictionary, agreed. Names of your cats. Anybody? Yeah?
List.
List? Yeah, it depends on how you feel about your cats. If you have a best cat, then, you have best cat, second best cat, third best cat, then yeah. The courses you took, the year you took them, and the grade you got. Yes? Dictionary? Yes. We're dealing with more than a little bit of, we're dealing with more than 2 pieces of data though, right? Yeah, like a nested data structure of some type. I would say like a dictionary leading to a tuple, maybe? Sure. Alphabetical class list. What do you think? Yeah. Sure, tuple. Perfect. At least past the add and drop date, because before that, you probably want a mutable data structure because it's going to change, right? So, the words of Alice's Adventure in Wonderland, like the text of a novel, is the ordering of the words in a book important? Then you would want an ordered data structure. Are the words likely to change? So you would want an immutable data structure. So you would want a tuple. Possibly also string, just saying, anyway. Frequency of words in Alice in Wonderland. Dictionary, very good. Financial portfolio with stonks and amounts.
Single value is 0.
Well, I mean, how many people in the finance program or the commerce program? Yeah, fair number. I would recommend recommend experts when it comes to finances and stuff. All the schools that you attended. List? I hear a list. What else do I hear?
Set.
Set, yeah. Well, there is an ordering, right? Because you did attend them in a particular order. But, yeah. Anyway, you guys get the idea, yeah? Good. So, let's see. We got 2 minutes left to think about. Oh, it's the make change problem. Okay. We're going to introduce the make change problem, and then we'll revisit it on Wednesday. All right? So, in programming, we have certain classes of problems which we consider to be hard. It's not necessarily, that doesn't necessarily mean it's hard to write an algorithm for them, although that can be the case. What it means is it's hard for the computer, right? This is one of those problems, although it may not seem it. So the make change problem is actually a general, it's a specific instance of a general problem called the knapsack problem. But essentially the idea is you have a transaction that occurs. There is a certain amount of change that's owed to you. You have this set of denominations of coins to give back to the person you owe the change to, what is the minimum number of coins that you can give them that forms the correct change? Right? So it's like there are going to be multiple correct answers, quote unquote, because there are multiple like ways you can give the change back, right? You can give this arrangement here, you know, for the target value of 185, you can give them a loonie, 3/4, and a dime. You can give it to them all in nickels. You could give it to them all in dimes, except for one last nickel. You could do all, like, the number of options are very large. So that's not really what the problem is. The problem is, it's a minimization problem. We're trying to minimize the number of coins that we're giving out. And whatever that minimum value is, that's going to be the most correct answer. But yeah, so anyway, that's the make change problem. We'll talk about it on Wednesday. Thank you very much for your time and attention, folks, and have a good week.